lecture number 1 for chemical bonding. I discussed about only one topics for this chapter. This is bond order. Bond order is determined in a particular molecules followed by the various steps. Step number 1, which molecules, step number 1, which molecules contain total number of electron less or equal to 14. That means in a particular molecules, first time count total number of electron, the number of total electron if less than 14 or equal to 14. That means lower the 14 or equal to 14, then their molecular orbit arrangement are followed by this: sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, pi 2px is equal to pi 2py, then sigma 2pz, then pi star 2px is equal to pi star 2py, finally sigma star 2pz. This procedure for less, which molecules total number of electron less or equal to 14, this condition apply for this arrangement of the molecular orbital. First time we know the confusion part is the sign of star mark and without star of sign marks. The star marks denoted by anti-bonding orbital, and without star mark denoted bonding orbital. Without star mark denoted by bonding orbital. If total number of electron less or equal to 14, then this special arrangement of molecular orbital, each one of the molecular orbital arrangement this followed by this energy mechanism, less. That means the higher energy of molecular orbital should be sigma star 2pz. That means anti-bonding 2pz of molecular orbital has higher energy level. This order is energy increasing order. We know that from the chapter number 2, the structure of atom, we know that the followed by the principle of above principle, we know that electron are always enter first time lower energy orbital. So this is the energy order of the molecular orbital. Lower the energy of the orbital has first time electron enters the which orbital? This orbital which are lowest energy. That means the lowest energy of the molecular orbital is sigma 1s, then sigma star 1s, then energy are also increasing sigma 2s as it is followed by this process. Per molecular orbital, maximum content number of electron is 2 per molecular orbital. Each molecular orbital contain maximum number of occupy electron 2. By this follow as example for CO species, that means carbon monoxide. Carbon monoxide first time step 1 counting total number of electron. First time step 1 total number of electron counting. This species carbon content 6 electron, oxygen content 8 electron, so total number of electron in this species of carbon monoxide is 14 electron. Then total number of electron followed by this process is condition is which molecules contain total number of electron less or equal to 14. So it is equal to 14 number electron, then the arrangement of the molecular orbital should be as it is: sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, pi 2px is equal to pi 2py, sigma 2pz, then pi star 2px is equal to pi star 2py, then sigma star 2pz. Each molecular orbital maximum number of electron 2. So fill up by the electron. First molecular orbital 2, second molecular orbital electron maximum content 2, as it is 2. So total electron count 2 to 4 to 6 to 8, remaining 6, total electron number of 14, then counting total 8, as it is 2 2 must be kept in mind. These two molecular orbital is equal to sign, that means two molecular orbitals are equally distributed electron, not can never 2, the number of electron pi 2px is equal to 2, pi 2px is equal to 1. It cannot never this followed. Always distribution of equal number of electron, that means the equal sign is significance that the two molecular orbital are same energy level, so they are occupying in same number of electron, and the number of electron can be distributed equal quantity. So pi 2px is equal to pi 2py. So fill up to 2 to 4 to 6 to 8 to 10 to 12, then 14. The total number of counting up to sigma 2pz. The counting procedure, next count bonding electron. Previously I say that the star mark is anti-bonding orbital and without star mark bonding orbital. So bonding electron, that means the electron are occupy in bonding orbital, that means bonding orbital without star mark, sigma 1s, sigma 2s, pi 2px, pi 2py, sigma 2pz. These are bonding orbital because without star mark denoted bonding orbital. So bonding electron should be count sigma 1s number of bonding electron 2, sigma 2s number of bonding electron 2, pi 2px number of bonding electron 2, pi 2py number of bonding electron 2, and then finally sigma 2pz the bonding electron 2. So total number of electron in bonding orbit 2 to 4, 6 to 8 to 10. Similarly anti-bonding orbital, anti-bonding electron counting. We know that the star mark is occupy anti-bonding orbital, so sigma star 1s, sigma star 2s and pi star 2px and is equal to pi star 2py, and also sigma star 2pz are anti-bonding orbital. Anti-bonding electron has present in anti-bonding orbital. So total number of anti-bonding electron, star mark 2 electron, so total number of anti-bonding electron 2 plus 2, that means 4. Next this process, the formula of bond order. The formula of bond order in a molecule BO, that means bond order is equal to NV minus NA by 2. What is NV? NV denoted by number of bonding electron, NA number of anti-bonding electron. So NV means bonding electron counted 10, anti-bonding electron counted 4, divided by 2, that means 6 by 2, result bond order 3. So the compound carbon monoxide, this species, the bond order is 2. This is the step number 1, and next step is greater than 14. If total number of electron in a molecule is greater than 14, then the arrangement of molecular orbital some changes. These are condition for total number of electron. If condition for total number of electron in a molecule greater than 14, then the arrangement of molecular orbital should be sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, sigma 2pz, then pi 2px is equal to pi 2py, then pi star 2px, then pi star 2px is equal to pi star 2py, finally sigma star 2pz. These are molecular arrangement of orbital for condition for if total number of electron in a molecule greater than 14, then this arrangement. This is the order of molecular orbital energy order. This is the energy order of molecular orbital for the total number of electron greater than 14 species. As example, CO minus. As example for a molecular species CO minus, then first time count, step 1 count total number of electron. Carbon monoxide occupy carbon and oxygen. Total number of electron carbon 6, total number of oxygen 8. This is the total number of electron, but the significance of minus sign, that means negative charge determine the one extra electron occupy this molecule. Negative charge always determine the one electric charge, one electron are excess in this molecule, so we can add one electron extra, then total number of electron 15. So this 15, total number of electron 15 can follow this condition for total number of electron greater than 14. This is 15 greater than 14 supporting this formula. So the arrangement of the molecular orbital as it is sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, sigma 2s, sigma 2pz, pi 2px is equal to pi 2py, then pi star 2px is equal to pi star 2py, and finally sigma star 2pz. Each molecular orbital maximum contain 2 electron. So first time occupy full electron, first orbit 2, second to 2 to 4, 4 to 6, 6 to 8, 8 to 10, 10 to 12, 12 to 14, and remaining 1 electron should be this arrangement. This is the diffuse condition for the pi 2px is equal to pi star 2px is equal to pi star 2py. This indicate, so equal sign indicate that two molecular orbitals have same energy level. So remaining 1 electron, up to this side 14 electron counted, remaining 1 electron are occupy which orbit, pi star 2px or pi star 2pi. This condition, if even number of electron are the remaining even number of electron are present in species, so the remaining 1 electron can occupy or either pi 2py or either pi 2px. That means in two orbital, any one of the orbital contain 1 electron. Any one of the molecular orbital contain 1 electron. The total number of up to counted 14 electron. Next remaining 1 electron which orbital occupy. These are arrangement. Pi star 2px is equal to pi star 2pi. Equal sign indicate the energy are same level. So 1 electron can occupy any one of the molecular orbital, pi 2px or pi 2py. So we can 1 electron are position 1. You know that 1 electron can be replaced by this or molecular orbital. This does not matter. Pi 2px is equal to pi 2py. So the bond order of the molecule. So bond order of the molecule formula Nb minus Na by 2. Nb, that means number of bonding electron. number of bonding electron without star mark is bonding orbit. Without star mark, bonding orbit, sigma 1s bonding orbital, sigma 2s bonding orbital, sigma 2pz bonding orbital, pi 2px, pi 2py, this is bonding orbital. So number of bonding electron, sigma 1s 2, sigma 2s 2, sigma 2pz 2, pi 2px 2, pi 2py 2. So total number of bonding electron 10. Number of anti-bonding electron Na, that means star mark. Star mark are denoted by anti-bonding orbital. So anti-bonding electron occupy in anti-bonding orbitals. Sigma star 1s anti-bonding electron 2, sigma star 2s anti-bonding electron 2. As it is pi star 2px anti-bonding electron 1. So 2 2 4 1 5. Then this put this value, this equation, Nv 10, Na 5 by 2, so 5 by 2, 2.5. So bond order in a molecule are followed by two steps, less or equal to 14 electron, and second is greater than 14 electron. Two systems are occupied by molecular orbital arrangement according their energy order. Also short tricks also present for MCQ, for NEET and others competitive exam. This is the elaborate process for school exam or CBSE or ICSE exam, but in NEET or others competitive exam the method is very fast. So this is the short tricks of the method. We remind a table which can help you for quick answer for bond order in a molecules. Table: total number of electron, bond order. If total number of electron 10, then bond order value is 1. If total number of electron 11, then bond order is 1.5. Total number of electron, if any space is 12, then bond order 2. 13 electron total number of electron, bond order 2.5. 14 total number of electron, bond order 3. Total number of electron 15, bond order 2.5. 16 2, 17 1.5, and 18 bond order 1. This is the total number of electron up to 10 to 18. This formula is valid for total number of electron 10 to 18. Then less than 10, in which spaces are contained less than 10 electron, then you can study the elaborate process, that is molecular orbital arrangement. If total number of electron 10 to 18, then very first bond order value is this table. But less than total number of electron less than 10, then the process is the elaborate process of arrangement of molecular orbital, sigma 1s, sigma star 1s, this process. But 10 to 18 is quick, very quick for NEET and others competitive. Then if total number of electron, as example, suppose NO, MCQ for NEET, NO, CO, N2 plus, NO, CO, N2 plus. First time count total number of electron. NO, N, total electron 7, oxygen electron 8, so total number of electron 15. Carbon monoxide total number of electron 6, oxygen 8, so 14. N2 plus, N2, nitrogen electron 7, molecule atoms 2, plus sign, other upper sign is plus, so electron deficient. Plus means cation, cation means 1 plus means 1 electron deficient. So total number of electron 13. So we concluded that total electron in this species 13, 14, 15. So we can rewind this table because this table is valid for total number of electron 10 to 15, 10 to 18. So N to bond order for electron 15, 2.5, as it is from the table, above the table. 14 2, total number of electron and bond order up to valid 10 to 18. So total number NO species is a total number of electron 15. Electron 15. So it is bond order 2.5. 14 bond order 3 as it is above the table, and N2 plus bond order 13. So total number of electron 13. So bond order as it is table 13 for 14 for 3, then 13 for 2.5 as it is result, because we know that bond order 10, total number of electron 10, bond order 1, total number of electron 11, bond order 1.5, 12 total number of electron, bond order 2, 13 total number of electron 13, bond order 2.5, 14 bond order 3, 15 bond order 2.5, 16 bond order 2. So this table quick method 15 total number of electron 15, so bond order 2.5, total number of electron 14 for so bond order 3, total number of electron N2 plus 13, so bond order 2.5. This is the quick method for competitive exam. As it is table, it is valid only for total number of electron 10 to 18. Then remaining less than 10 total number of electron molecules can method of the elaborate process, that means arrangement of molecular orbital, bonding orbital, first time determine bonding orbital, bonding number of total bonding electron, anti-bonding electron, and next finally NB minus NA by 2, this method. This is the complete determined process of bond order, and also bond order application also the competitive for this competitive exam bond order, the application of bond order is huge applicable. This application also mentioned by this process. Next topic is the application of bond order. The application of bond order. Rules 1. Application of bond order for rules 1. Bond order BO, that means bond order. Bond order inversely proportional to 1 by bond length. That means, what is the meaning of this? Bond order inversely proportional to 1 by bond length. That means if bond order increases, then bond length BL, that means bond length decreases. If bond order decreases, then bond length. For an example, if question for NEET N2 plus and N2 minus, this is the three species of molecules. Question increasing bond length, increasing bond length order. Arrangement, this is the process of arrangement of increasing bond length. So first time the process 1, counting total number of electron. Total number of electron, nitrogen 7 into 2, that means 14. N2 plus total number of electron, N2 plus nitrogen 7 into 2 plus means 1 electron deficient, that means 13 electron. Finally N2 minus total number of electron N2 7 into 2, charge minus charge, that means 1 electron excess, so 15. Total number of electron 15. We know that above the previous copy, the table of bond order and bond length up to valid total number of electron 10 to total number of electron 18. The total number of electron 14. So bond order 14, bond order 3, 13 bond order 2.5, 15 bond order, total number of electron 15, so bond order 2.5. So we know that the formula bond order inversely proportional to bond length. That means if bond order increases, then bond length decreases, or alternative form, bond order decreases, then bond length increases. So the order of increasing order of bond order of these three molecules, highest number of bond order 3, so, and the lowest, then the bond order of first time N2 total number of electron 14, then bond order 3, so it is a maximum bond order. So N2 plus N2 is maximum bond order. Then this is the equal number of bond order. So we can write this N2 plus is equal to N2 minus. This is the order due to same bond order 2.5. So increasing bond length order according to formula, increasing bond length of these three molecules, increasing bond length. We know that the formula, if bond order increases, then bond length decreases. Bond order increases, then bond length decreases. So equal number of bond order N2 plus and N2 minus 2.5 and 2.5. So this is the bond length also equal. Bond length N2 plus and is equal to N2 minus due to same bond order, same bond length. But the maximum bond order N2 species maximum bond order 3. So it has lowest bond length because it is a relation of inverse relation. Maximum bond order, minimum bond length. So minimum bond length, this is N2 is minimum bond length due to highest or maximum bond order. This is the first application of bond length and bond order. Next bond order rules 2. Rules 2, bond order directly proportional to bond dissociation energy. Bond order directly proportional to bond dissociation energy or stability. What is the meaning? That is the bond order directly proportional to bond dissociation energy or stability. That means if the value of bond order increases, then BDE, that means bond dissociation energy or stability, increases. If bond order value decreases, that means lower value, then bond dissociation energy or stability decreases. This is a direct relation. That means if bond order increases, then bond dissociation energy also increases. If bond order decreases, then BD also decreases. For example, O2, as the example, O2 plus, O2 2 minus. This is the superoxide ion. Most important for superoxide ion, O2 plus and O2 minus. First time, step 1, total number of electron. O2 total number of electron, oxygen electron 8 into 2, that means 16. O2 plus total number of electron 8 into 2, 16. Plus species, that means 1 electron deficient, that means 15. O2 2 minus total number of electron, O2 1 oxygen electron 8, 2 electron, 2 molecule, 2 atoms, so 8 into 2 minus, that means total minus species denoted by excess of electron. 2 minus means total add 2 electron, excess electron. In chemistry, minus for rich person and positive for poor person. So minus sign denoted excess electron. Total number of excess electron 2 minus. So excess electron 2. These electrons are added. 8 into 2, 16 plus 2, 18. So we also know that from the bond order and total number of electron table, 16 up to 14 bond order 3. Total number of, if total number of electron 14, then bond order 3. If total number of electron 14, then bond order 3. If total number of electron 15, then bond order 2.5. If total number of electron 16, then bond order 2. If total number of electron 17, then bond order 1.5, and 18 bond order 1. So 16 bond order 2. 15 bond order 2.5. So as this is the last total number of electron 18, so bond order 1. Then first time the arrangement of bond order. Highest bond order 18, highest bond order 2.5, sorry, O2 plus. So maximum bond order O2 plus, next 2 O2, then lowest 1 bond order O2 minus, that means superoxide ion, O2 minus. This is the arrangement of bond order, but your question is arrangement of the bond dissociation energy or stability. The relation of bond order and bond dissociation energy, direct relation. Bond order increase, BD increase. Bond order decrease, BO increase. Bond order decrease, so bond order decrease, so BDO also decrease. That means direct relation. So arrangement of BDE arrangement, that means bond dissociation energy arrangement of these molecules. Direct relation. So highest bond order value, highest bond dissociation energy. So O2 plus maximum bond dissociation energy, then O2, and finally lowest bond dissociation energy, superoxide ion, O2 minus. So the application of bond order, the first rules 1, if bond order is inversely proportional to 1 by bond length, that means if bond order increases, then bond length decreases, that means opposite signification. One increases, then other quantities decreases. And next rules 2, bond order directly proportional to BD. Bond order directly proportional to BD. That means bond order directly proportional to BD means if bond order increases, then bond dissociation energy also increases. That means same manner, following function is same manner. So this is the example. This is huge application of for competitive exam, for NEET, JEE and others exam. This is the short method for table. Table is very important for competitive exam, but in classroom program, the elaborate process, the first video, this is the elaborate process. That means the application of the details is applicable when the total number of electron less than 10. Then we can find the arrangement of the molecular orbital. That means sigma 1s, sigma star 1s, sigma 2s, as it is. Okay. This is the application of bond dissociation energy. Then next topic 6. Next topic, the paramagnetic and the diamagnetic nature. Then the next topic, paramagnetic and diamagnetic nature. What is the paramagnetic? Next topic is.
This is part of bond order. This is part of bond order.
This is the part of bond order.
Okay.
This is the part of bond order. That means paramagnetic nature, oblique diamagnetic nature. Which molecules are paramagnetic, which molecules are diamagnetic? Determined by bond order value, BO value, that means bond order value. If bond order value, fraction number, that means decimal number, fraction number or decimal number means point number, decimal number, that means 1.5, 2.5, this is the fraction part. If bond order value, fraction number or decimal number, then this molecule paramagnetic, then this molecules paramagnetic. If BO, that means bond order, if bond order value simple number simple number, that means 1 2 3 4 as it is number, then this compound, then these molecules diamagnetic. So this is the rules for diamagnetic and paramagnetic. If bond order value, the bond order value is fraction value or decimal number, that means point number 1.5 2.5 3.5, this is the result, then these molecules are paramagnetic. But which compounds are bond order value simple number, that means normal number 1 2 3 4 as it is, this number 1.5 2.5 3.5 4.5, that means decimal, that means point system. Point number means paramagnetic, which value? Bond order value. If bond order value simple number 1 2 3 4, then this molecules is diamagnetic. But sometimes also problem occur in few elements, their number, that means fraction number and simple number cannot define what is paramagnetic and diamagnetic, then this process is not valid. But maximum number of molecules are also determine the paramagnetic and diamagnetic in this method. So as example, NO and C2. First time step 1, total number of electron. TNE, that means total number of electron. Nitrogen 7, oxygen 8, total electron 15. C2, total number of electron. TNE, total number of electron. C2, carbon 6 into 2, 12. So bond order 15 total number of electron 15. So bond order, total bond order 2.5. If total number of electron 12, so bond order 2. So bond order 2. So then the number of value of bond order fraction 2.5. Number of bond order value 2.5, that means fraction number or decimal number. So this compound paramagnetic, this compound paramagnetic, this value, this bond order value simple number 2, so it is, so C2, so C2 is diamagnetic, so C2 is diamagnetic. This is the method for paramagnetic and diamagnetic nature following this element. This method, if fraction value, then paramagnetic, and the normal value diamagnetic. But the paramagnetism or magnetic dipole movement in a compound, magnetic dipole movement in a molecule, magnetic dipole movement, determine magnetic dipole movement in a molecule. Magnetic dipole movement is denoted by mu. Mu is equal to root over n into n plus 2 unit Vm, B dot capital M. Magnetic dipole movement in a molecule, determine this formula, mu is equal to root over n into n plus 2. What is n? N, number of unpaired electron, number of unpaired electron. Example NO. Example NO. Counting first time, total number of electron. Total number of electron, nitrogen 7, oxygen 8, 15. So total, if we know that if total number of electron greater than 14, then arrangement of the molecules. If total number of electron greater than 14, then arrangement of the molecules, sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, pi 2px is equal to pi sigma star 2s, then sigma 2pz, then pi 2px is equal to pi 2py, then pi star 2px is equal to pi star 2py, then finally sigma star 2pz. So total number of electron 15. So this is the rule number 2, greater than 14 electron, then arrangement this process. total number of electron 15 for NO. First orbit 2, maximum each orbit contain maximum 2 electron, 2, 4, to 6, to 8, to 10, 10 to 12, to 14, then remaining 1 electron in between 2 orbit, 2 equal sign denoted equal energy. So 1 electron can occupy either pi 2px or pi 2py. So bonding electron. So number of unpaired electron. Each molecular orbital contain paired electron, 2 paired electron, 2 paired, but unpaired electron means 1. This is the unpaired electron. Remaining are all paired electron. The magnetic dipole moment formula mu is equal to root over n into n plus 2. N is number of unpaired electron. So the molecular species NO contain 1 unpaired electron, 1. This is the number of electron 1. This electron are unpaired, but all the remaining are paired. Number of 2 electron means paired electron. So number n is equal to 1. So n, that means number of unpaired electron. Unpaired electron number is 1. So magnetic dipole moment, magnetic dipole mu is equal to root over n into n plus 2. That means n is equal to 1, 1 plus 2. That means root 3. The value of root 3, 1.732. Unit of magnetic dipole moment, mu is equal to dipole moment unit Vm. So this is the determination process of magnetic dipole moment in a molecules, followed by the bond order respectively. The bond order, the n denoted by number of unpaired electron. First time counting total number of electron, then rules 1 and 2, which is applicable. Get the total number of electron 15, so rules number 2, greater than 14 electron. So the arrangement of the molecular orbital, this followed by this mechanism. Each molecular orbital contain maximum number of 2 electrons. So we can fulfill 2 electron each orbit. So up to this 14 electron counted. Then remaining 1 electron. The 1 electron can occupy either pi 2px or pi 2pi, but 2 energy are equal level. So we can position of 1 electron either pi 2px or pi 2pi, any of the 2 orbit. So total number of, then next step, number of unpaired electron. Unpaired electron means each molecular orbital contain number of 2 electron. That means paired electron. Unpaired electron number only 1. 1 is unpaired number. So number of unpaired electron is 1. So n value, this n value is 1. And then finally the determinant of mu. Mu is equal to root over n into n plus 2. This process also reverse process, or question also be reverse process. That means given data, in a question, given data, magnetic dipole moment is given. In a molecular species, magnetic dipole moment is given, then determine the number of unpaired electron. Same question but reverse order. This question, determine magnetic dipole moment for NO molecules. Then first time you determine number of unpaired electron. Then the put of n value, this process. But question is reverse question. If given data, the magnetic dipole moment in a molecules are given by any number, then you find out the number of unpaired electron. Totally reverse question also be founded. As an example, we can understand this question. If given data is mu value given, that means magnetic dipole moment given, then find out number of unpaired electron. This is the question. We can write this purpose one question. In a molecular species, in a molecules, the numerical value of magnetic dipole moment, the numerical value of magnetic dipole moment 1.732. Then find out unpaired electron of the molecule. Unpaired electron in this molecule. in this molecule. This is the question, the reverse question of the magnetic dipole moment. The given data, mu data is given, magnetic dipole moment is given, then find out unpaired electron. That means calculate n value. N means number of unpaired electron. So we put the formula mu is equal to root over n into n plus 2. Mu value is given. That means magnetic dipole moment. Magnetic dipole moment is denoted by mu. Mu data is given. What is the number of mu? Numerical value 1.732. So we put this number 1.732 root over n into n plus 2. Then we know that 1.732 is equal to root over 3. We know that root over 3 value is 1.732. So we can replace 1.732 by root 3. Then root over n into n plus 2. Next step, both sides square. Root 3 square 3 and root over n into n2 plus square. That means root is cancel out. So remaining number n into n plus 2 is remaining portion. Then next time calculation, n into n plus 2 multiplication, n square plus 2n is equal to 3. N square plus 2n minus 3 is equal to 0, or n square 3 minus 1 into n, that is the middle term process, plus 10. N square plus 3n minus n minus 3 is equal to 0. So n plus 3 minus 1 common, n plus 3 is equal to 0. At last the value of n plus 3 is equal to 1 into n minus is equal to 1. So either n plus 3 is equal to 0, that means n value is minus 3. It is not possible. Minus 3 is not an unpaired electron significance number. Minus number cannot possible for unpaired electron number. Another possibility, n minus 1 is equal to 0. So n is equal to 1. So this is the right answer. So n value is given. N is equal to 1. So the unpaired electron of the molecules 1. The previous question data, the unpaired in a particular molecules determine the magnetic dipole moment. Then we can follow the step. First time the total number of electron, then the arrangement of the molecular orbital. Next the unpaired electron is given. So but this question is totally reverse question. The magnetic dipole moment is given, then find out the unpaired electron. So this is the process. To determine this question, you can remember this root value. Root 2 1.414, root 3 1.732. So this number can replace this number. Then the calculation is easy. But 1.732 is equal to root over n plus 2. This both sides square and then milligram. It is not possible. It is very elaborate process and time management is टाइम मैनेजमेंट के लिए बहुत समय लगता है. सो दिस प्रोसेस टू रूट 2 एंड रूट 3 वैल्यू कैन रिमेंबर बिफोर दिस क्वेश्चन. सो 1.73 इक्वल टू रूट 2 root 3, 1.732 is putting by the root value root 3. Then the calculation process is easily collaborate with you. So remember must be root 2 and root 3 and also root 5, root 2 and root 3, root 5, root 7. This 4 value must be remember following this question. Then you can find out the total number of unpaired electron in a molecules easily. Then this is the topic of application of bond order. Then find out the topics is the determination of bond order. That means how you find out that bond order, the rules 1 and rules 2 for less or equal to 14 number of electron, and second rules is greater than 14 number of electron. Then the application of bond order is very important for competitive exam. First rules, bond order inversely proportional to 1 by bond length. Bond order inverse directly proportional to bond dissociation energy. Then last topic is for bond order. This is the last topics for bond order. That means real existence of a molecule, is it yes or no? In a molecule are real existence in nature. That means as real existence of a molecule in nature, of a molecules in nature. How it is possible to solve this problem? So we can this problem is solved by bond order method. If bond order value is 0 or negative number. If bond order value is 0 or negative number, then these molecules cannot exist in nature. What is the problem? Real existence of a molecule in nature. This problem is solved by this method. If bond order value is 0 or negative, then these molecules cannot exist in nature. As example, Ag2, helium 2. These molecules has real existence in nature. Then find out bond order. Then find out total number of electron. Ag, helium 2 electron. But species. Please remember this. All the notes please छाप लो किताब में. And this the last procedure for application of bond order. Ag2, total number of electron 4. So the arrangement, these rules followed by these rules. Total number of electron less than 14. But we say that the table of bond order and bond length. The table of bond order and total electron number of electron, bond order and total number of electron in a table, it is valid up to 10 electron to 18 electron. This bond order value is applicable. 10 for 1, 18 for bond order 1. But less than 10, then helium molecules total number of electron less than 10. So this process cannot be given from this table. This is not possible. So arrangement of this molecule, total number of electron 4, this is the less than 14. So order of the sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, pi 2px is equal to pi 2py, then sigma 2pz, pi star 2px is equal to pi star 2py, then finally sigma star 2pz. So total number of electron 14. Each molecular orbital contain maximum 2 electron, 2 to 14. This is complete electron. So number of bonding electron, that means NB. Number of bonding electron means NB. Bonding electron without star mark is bonding electron 2. Number of anti-bonding electron, that means N suffix A. Number of anti-bonding electron 2. Star mark is anti-bonding orbital. Anti-bonding orbital occupy anti-bonding electron 2. So the bond order value formula, bond order NV minus Na by 2. Bonding electron, NB means number of bonding electron 2, number of anti-bonding electron 2 by 2, result 0. So bond order value is 0. This is the method. If bond order value is 0 or negative, then these molecules cannot real existence in nature. So Ag2, this is the bond order of 0. So these molecules cannot exist in nature. So this is the full process of bond order and application of bond order for competitive exam and board exam. This is the complete method for the bond order and its application of bond order. Thank you. Complete this video.
অনেক বড় ভিডিও ছিল এটা।